Hello, everyone. Welcome. Thanks for joining me again. So in this video, I'm going to be working out Math 190 sample final. Feel free to look at the PDF file first and then work out the questions. Then you can check your answers with mine. So let's get started. So for the first question, we're going to perform the indicated operation and simplify. So let's call this file. This will be the solutions file. So first thing we're going to do is to combine this compounded fraction, we're going to combine the top. So we need the least common denominators. So the LCD for the top two fraction would be 10. So I would multiply 2 over 5 by 2 over 2. So that will give me 4 over 10 plus, and then 1/2 I'm going to multiply with 5 over 5. So that will give me 5 over 10. And then for the denominators, for the bottom two fractions, our LCD is going to be 15. So we're going to multiply 1 over 5 by 3 over 3. So that'll be 15 in the denominator. So that's 3 over 5 minus, and the second fraction, there's no need to change because it already has 15. All right. So now if you combine the top, that will be 9 over 10 divided by 3 minus 6, that would be negative 3 over 15. And now we can do 9 over 10 times the reciprocal of the bottom fraction, negative. You could put the negative on the bottom, doesn't really matter. So I'll just write 15 over negative 3 to keep it consistent. And now we can simplify this. So we can reduce these numbers, 10 and 15. So that would give us a 2 here and a 3 here. So they can be reduced by 5. And then 9 and 3, we can also reduce them. So this 3 will cancel with that. I'll be leaving you with the 3. So what we're left with, it's simply just 3 times 3 on the numerator, that's 9. On the denominator, negative 2. So our answer for this question is negative 9 over 2. So let's put that right here. This is negative 9 over 2. All right, so moving on to the next problem. So for the next problem, we're going to be evaluating this by using the laws of exponents. So I see all of this to a negative power, so let's reciprocate the fraction. So that would be 81 over 64 to the power of positive 1/2. And then here you can write this as a square root of 81 over a square root of 64, because that's where power of 1/2 is. Then this will simplify to square root of 81, that's 9, and square root of 64, that's 8. And 9 and 8 has no common factor, so this will be your final simplified answer. All right, for number 3, we're going to be performing the multiplication. So that means you distribute. So distribute this with that, and then this with that. So when you do 3x times 3x, you'll have 9x squared. 3x times 4, that's about 12x. And then we do the same thing with these terms. So negative 4 times 3x and then negative 4 times 4. So that would give us negative 12x, and then negative 4 times positive 4, that's negative 16. And now here you realize these are like terms, so they cancel each other. So our final answer will simply be 9x squared minus 16. All right, so moving on to number 4. For number 4, we're going to factor this. Let's take out the common factor. That will be z. So you would have z squared minus 2z minus 3. Now this one you can factor further. So this is going to be factored into z here and a z here. So you need product of two numbers to give you negative 3, sum up to negative 2. So I need a negative 3 and plus 1. So that works. So this will be the completely factored form. All right, so here's number 5. We're going to perform the multiplication and simplify. So we're going to go ahead and factor everything. So I'm going to factor x squared minus 36. That's a difference of two perfect squares that can be factored into x plus 6 times x minus 6. And the denominator, you can factor this into also a difference of two perfect squares. So this would be x plus 4 times x minus 4 times. And then for the second fraction, here I can just pull out the GCF on the numerator, which is 2 times x plus 4. And the denominator is just x minus 6. Let's put parentheses around. All right, now let's cancel common factors. So we see that from here, x plus 4 will cancel. And then x minus 6 will cancel. So our final answer for this will just be 2 times x plus 6 on the numerator and x minus 4 on the denominator. Feel free to leave it right here, or if you want to be fancy, you can distribute the numerators. So you'll have 2x plus 12 over x minus 4. Any of these are fine and totally acceptable. Okay, so moving on to the next question. We're going to perform this addition and simplify. So we need LCD that will work with all three fractions. So the LCD, the least common denominator that will work for all three fractions is x squared. It's the term with the highest power, which means I can write this as over 1 and multiply it by the LCD. So that would be x squared over x squared. The second fraction already has an x in the denominator, so you just need one more factor of x. So that'll be 2x over x squared. The last one, of course, doesn't need anything, so you just rewrite. And now we can combine the numerators. So it would be x squared plus 2x plus 3 over x squared. Now you try to see if you can factor the numerator, and it looks like it's not factorable further, so I'm going to leave it right here. So that will be our combined expression for this. All right, moving on to number 7. So for number 7, we're going to find an equation of the line passing through this point and also parallel and point to this line, which means I need to borrow the slope of this line. Where's the slope? So you're going to write this in mx plus b form. Solve for y. So you will have 3y is equal to subtract 2x plus 4. Then divide by 3. So y is equal to negative 2 over 3x plus 4 over 3. So here's the slope that we want to borrow. Since it's parallel, our slope, m, it's going to be the same. So here's the slope, and the point we're going to use 0, negative 2. So our equation in point slope form, y minus y1 equals m times x minus x1, it's going to be the following. So we have the slope, call this one x1, call this one y1, plug them in. So this is y minus negative 2 equals negative 2 over 3 x minus 0. You can clear this up and write it a nicer way. This will be y plus 2 equals negative 2/3 x. You can leave it right here or just subtract the 2. Either way, both are equivalent. All right, here's the next question. We're going to go ahead and solve for x. So let's go ahead and subtract 2 first. So we have the radical expression isolated. So this would give us the square root of 6x plus 4 is equal to x minus 2. And now we're going to go ahead and square both sides to get rid of the radical. This would give us 6x plus 4 is equal to the right-hand side you're going to have to expand. That would be x squared minus 4x plus 4. And now let's move everything to one side. So I'm going to subtract 6x from both sides and subtract 4. So we set it to 0. So you have 0 equals x squared minus 10x. 4 and negative 4 cancels out. And this I can factor. So it'll be x times x minus 10, which means x is equal to 0 and 10. And we have to check our answer. So let's go ahead and do the check on the side. Since it's a radical equation, you have to check. Plug in 0. So you'll have a square root of 6 times 0 plus 4 plus 2. Is that equal to 0? So 6 times 0, that's 0. Plus 4, that's going to be 4. Square root of 4 is 2. So you have 2 plus 2. That's not equal to 0, which means this doesn't check. Now, for the second one, x equals 10, you have square root of 6 times 10 plus 4 plus 2, is that equal to 10? Well, let's see. So 6 times 10, so that's 60. Plus 4, that's 64. Square root of 64 is 8. Plus 2, is that 10? Yes. So the only solution is x equal 10. That would be the only solution to this equation. Okay, so for number 9, we're going to evaluate and simplify this expression using this function. So first, you're going to compute g of 5. So plug in 5 into t. So that would give you 2 times 5 squared. That would be 2 times 25, which is 50. And then you will evaluate g of a plus 5. So that would be, again, plugging in a plus 5 into t. So that's 2 times a plus 5 squared, which is 2 times a plus 5 squared is simply a squared plus 10a plus 25. Then here we distribute out the 2. That would give us 2a squared plus 20a plus 50. So this is our expression for g of 5. This is our expression for g of a plus 5. And then when you want to compute this difference, you simply take the second answer, which is 2a squared plus 20a plus 50, and you take away g of 5, which is just 50. And then here we can distribute the negative, so that's just minus 50. And here we see that these guys will cancel out. So all of this will just simplify to 2a squared plus 20a. So that will be the expression for g of a plus 5 minus g of a. For the next one, we're going to find all solutions to this equation. I'm going to go ahead and square root both sides. So you have x minus 4 is equal to plus and minus square root of 5. And then we add 4 to both sides. So x is equal to 4 plus and minus square root of 5. So that would be the answer to this equation. For 11, we're going to find the domain and range of this function. Now, if you look at this, this is the degree 2 polynomial. So degree 2 polynomial, which means that the domain is going to be all real numbers. So the domain of this function is negative infinity to infinity. Now, what about the range? Well, if you were to draw this polynomial to have an idea of what the range is, it's a parabola facing downward because of the negative x squared term. So it's going to look something like this, roughly sketched. Now we want to know how high will this go? Well, that's where the vertex is. So if you can find the vertex, the y-coordinate of the vertex, that's how far the range would be from negative infinity up to that point. So we know the vertex can be computed by x equals negative b over 2a. So if I plug in my b and a, so I know a is going to be negative 1, b is going to be 2, and c is 10. So if I plug this into my formula, x equals negative b over 2a, I have negative, so b is 2 over 2 times a is negative 1, which is positive 1. So this happens at x equals 1. Now, what's the y value? Because that's what we want. So I want to find f at 1. That would be 10 plus 2 times 1 minus 1 squared. So that would give us 10 plus 2 minus 1, which is 10 plus 1. That will be 11. So the maximum this will reach is 11. Therefore, the range for this function is going to be negative infinity. So all of these values down here, all the way up to the maximum. So that would be 11, including that point. So that will be the domain and range for this function. Okay, for number 12, we have a 21 feet ladder leans against a building. So that allows us to draw a picture like this. So let's suppose that's the building, and let's suppose this is the ladder, and this is the ground. So let me try to fix the corner. So something like this. So this is 21 feet. And so that the angle between the ground and the ladder, so this is the ground, that's the ladder, that's the angle. So that angle found to be 68 degrees. And we want to know how high does the ladder reach on the building. So this distance right here. So from here to here, that's what we're looking for. So we want to see which trig ratio relates these two sides. So if angle is right here, across from that angle is our opposite length, then this is our hypotenuse, this is adjacent. So we want to find a trig ratio that relates these two sides. So we know that sine of an angle is going to be opposite over hypotenuse. So that's what we're going to use. We'll use sine of 68 degrees. That is equal to opposite x over hypotenuse 21. And then I can solve for x. So x is equal to, multiply both sides by 21. 21 times sine of 68 degrees. Now, since we're not allowed to use a calculator, this is an acceptable answer. So for 13, we're going to evaluate sine of negative 5 pi over 3. So first thing I want to do is find the coterminal angle. So that's the one I will sketch. So let's go ahead and find the coterminal angle for this. So pretty much you take the angle and you add 2 pi, because 2 pi is 360 in degrees. So you multiply both 2 pi by 3 over 3, you get 6 pi over 3. Subtract 5 pi, you'll get pi over 3. So that's what we're going to sketch. So pi over 3 is 60 degrees. So your angle is right here, 60 degrees. So this is pi over 3, which is same as drawing negative 5 pi over 6, 5 pi over 3. So if you go around this way clockwise, this is negative 5 pi over 3. So you don't really have to find the coterminal, but it's always easier to actually work with the coterminal angle between 0 to 360. So now we can say that sine of negative 5 pi over 3 is exactly same as, since it's in the first quadrant, it's going to be positive sine of pi over 3. And we, of course, memorize this. So sine of pi over 3, that's going to be a square root of 3 over 2. So that will be the evaluation for this. All right, for the next problem, 14, we're going to evaluate cosine if we're given this trigonometric ratio, and theta is in the third quadrant. So we're going to draw our angle theta, third quadrant. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So our triangle looks like this. So you can imagine a bow tie, going around like that. Those are the triangle on that specific quadrant. So that's the one we want. So I'm going to go ahead and replace theta right coming up from the origin. You're given tangent, but we know tangent is opposite over adjacent. So you're given opposite and adjacent length, which means across from theta is the opposite, and this is the adjacent, and this is the hypotenuse. So that's our picture. So now let's fill this in. So our opposite is going to be 4, adjacent is going to be 3. Now, because you're on the third quadrant, these values are actually negative. So this is negative 4, negative 3. Because this is negative x-axis, this is negative y-axis, so they have to be negative. All right, so what are we looking for? Cosine. So cosine, by definition, it's going to be adjacent over hypotenuse. So I need to find what this is, and then I have cosine theta. We're going to be using Pythagorean's theorem. So we know that Pythagorean's theorem says if you square the sum of the legs, it is equal to the hypotenuse squared. So the legs are 4 and 3, so I can do negative 4 squared, 16, plus 3 squared, that's going to be 9. So now I can add them up, 16 plus 9, it's going to give me 25. So 25 is equal to c squared, which means c is equal to 5. We take the positive square root because hypotenuse can never be negative. So now I'm going to go ahead and erase x and label that to be 5. So we found hypotenuse. All right, now we can write down cosine theta. Cosine theta would be negative 3 over 5. There you go. That would be the value for cosine theta. For 15, we're going to solve this equation. We have an exponential equation. So I want to write both sides using same base. So all I have to do is rewrite this as an exponential form. So I have on the left side, 6 to the power of 3x minus 4. 1 over 6 can be written as 6 to the power of negative 1. Now, since both sides have same base, I can equate their exponents. So on the left side, my exponent is 3x minus 4. On the right side, my exponent is 1. So this equation only holds if their exponents are exactly equal. Now, algebraically, you can solve this. Add 4 to both sides. So you will have 3x is equal to 3. Divide both sides by 3, x is equal to 1. So there you go. That's the answer to this. You can check your answer by plugging it in. If you plug in for x, you'll get 6 to the power of 3 times 1 minus 4, which is negative 1. 6 to the negative 1 is 1 over 6. So it checks. All right. Wonderful. For 16, we're going to evaluate this logarithmic expressions. So I'm going to write it like this. So this is equal to log base 6 of 1 over 36, call it x. By using the definition, we can say this is 6 to the power of x is equal to 1 over 36. 36 can be written as 6 to the second power. And on the left side, you have 6 to the x. Now I'm going to bring 6 to the second power to the top. On the numerator, this is 6x is equal to 6 to the negative 2. So again, the only way this equation holds if their exponents are equal, so x must be negative 2. So there you go. That's the answer to this question. For 17, we're going to find the degree measure of this angle. So this is negative 3 pi over 2. So to do that, we're going to multiply this by 180 degree over pi and then simplify. So when you simplify this, you'll see that pi will cancel out. So negative 3 times 180 divided by 2, you'll have negative 270 degrees. So that will be the degree measure for negative 3 pi over 2. For number 18, we're going to find f inverse of 10 when f of x is this. There are multiple ways to do this. So the way I'm going to do it, if this is the input for the inverse, then it's the output for f. So I'm going to set x over x plus 2 equals to 10. So I want to know for over x value, I have 10. That's how f and f inverse are related. So we go ahead and solve for x. So we multiply both sides by x plus 2. You have x is equal to 10 times x plus 2. Here we distribute. This will be x equals 10x plus 20. And now we can subtract 10x from both sides. You'll have negative 9x is equal to 20, which means x is equal to 20 divided by negative 9. And you can just rewrite it like that. You can say that now f inverse of 10 is equal to negative 20 over 9. For 19, we're going to be solving this nonlinear inequality. So let's make sure one side is equal to 0. We'll subtract 8 from both sides. You'll have x squared minus 7x minus 8 less than or equal to 0. And then we factor. So this would give us x times x. So we need two numbers to multiply to give us negative 8, adds up to negative 7. So that would be negative 8 and plus 1. So the zeros of this inequality are 8 and negative 1. Now we plot them on the real line and see where is this inequality positive or negative. So here's negative 1, here's 8. Since the inequality is less than or equal to, we can include the endpoints. So this interval is negative infinity to negative 1. This interval is negative 1 to 8. This interval is 8 to infinity. Now let's test them. So first interval, I can test negative 2. Second interval, we can test 0. The last interval will test 9. So something easy and convenient. Let's plug them into the original, or actually this one right here. This is better. So when you, actually I'm gonna change my mind and go with the second one, the one that's factor. It doesn't really matter which one, but whichever is convenient. So when I plug in negative 2 in here and in here, you will get negative 2 minus 8, so it'll be a negative number, and then negative 2 plus 1, that will be a negative number. So two negative numbers, the product is plus. Here it's positive. And you do the same thing for the next value, 0. When you plug in 0 for each x in here and in here, you get -8. So this is a negative value. And when you plug in 9 for each x, you will get positive. So this is positive. And now if you look at the inequality, we want this product to be less than or equal to 0. So this means we want negative solutions or negative intervals. So that's only this one. So therefore, our solution to this inequality would be -1 to 8, including them. For number 20, we're going to be sketching this function using transformations. So first, we're going to identify our basic function. Our basic function will be square root of x. So if you ignore all of these, you'll see it's your square root of x, and then apply transformation. The first transformation we're going to apply is this one, which is a negative square root of x. So that's a reflection over the x-axis. So that'll give us negative square root of x. And then we'll do the x minus 6, which is horizontal shift. So we're going to shift 6 units to the right. So shift right 6 units. So that will take our first equation and shift right 6 units. That'll be the final picture. So here's our xy plane. And square root of x, we all know how that looks like. So it's just something like this. This is square root of x. If you reflect over the x-axis, so this is x, this is y, it would look something like this. That'll be negative square root of x. And then we shift 0.06 units to the right. So our final sketch would be 6 units right here. And then you just make the shape. So something like this. So this is negative square root of x minus 6. That's the equation. And this point is 6, 0. So there you have it. This is the final sketch of this equation. For 21, we're going to simplify this expression and eliminate any negative exponents. So there are multiple ways to do it. Again, I'm going to do it the way I think it's convenient. So first I'm going to do is combine these right here. Same base, I'm going to subtract their exponents. So you have y to the -2 over y to the -1. This would be y to the -2 minus -1 because I'm subtracting their exponent. And this is y to the -1. So this will become y to the -1 times z to the -3 all over 1. And both of them, since they have negative exponents, you can just put them on the denominator. So in the numerator, you have 1. The denominator, you have y, z to the 3rd. And these, we leave it right here. Since they're different base, you cannot combine their exponents. For 22, we're going to be graphing this piecewise function. So let's label our xy plane right here. This is our xy plane. And let's focus on this one right here. When x is less than or equal to 1, we have f of x is equal to x minus 1. So that's a line with slope 1 and y-intercept of -1. So it's in mx plus b form. So when x equals 1, you can plug it in. So f of 1 would be 1 minus 1. That would give us 0. So that's one of the points we know, and this is going to be closed because it's x less than or equal to. So here's 1, and 1, 1. When you plug in 1, you get 0. So you'll have this point right here closed. And this is a line with positive slope. So you can see which direction the line is going. But if you're not sure, plugging another point that's on the interval less than 1. So let's say 0. So if I want to find f of 0, I plug it in. I'll have 0 minus 1. That's -1. The -1 is right here. And you just connect them to the left like this. So that is your line. F of x equals x minus 1. Only when x is less than or equal to 1. For the second piece, we are going to be graphing x squared when x is greater than 1. So when you plug in 1 into x squared, you'll have f of x equals 1 squared, which is 1. Now this point is going to be open because the inequality is strictly greater than 1. So 1 comma 1, it's going to be somewhere right here. So I'll show that with a different color. So here's 1, and 1 comma 1 is right here. So it's a parabola going upward. If you're not sure how to direct, plug in another point greater than 1, and you'll see the graph. So it'll be something like this. So this is your function, f of x equals x squared, only when x is greater than 1. So together, we create this piecewise function. For 23, we're going to be sketching this function and labeling all intercepts. So this is a higher degree polynomial. First thing you want to do is find the zeros, meaning the x-intercepts. So I will set h of x to 0. So that would give me 0 equals x to the 4th minus 4x squared factor. So you have pull out an x squared times x squared minus 4, which can be factored further as x squared, x minus 2, and x plus 2. So the zeros are x equals 0 to negative 2. And now we can test. So just like we did it for inequality, we can do it for this function as well. So let's plot them. Here is negative 2, here is 0, here is 2. So now we're going to plug in a test value and plug it into, now this is easier to plug in. I want to see if the function is positive or negative. So let's pick negative 3 in this interval, negative 1 in this interval, 1 in this interval, and 3 in this interval. So I can express h of x as these guys because that's how you factor it. So you have x squared times x minus 2 and x plus 2. Let's plug in negative 3. So when you plug in negative 3 in here, and in here, what do we have? So when you square negative 3, it's going to be positive. Negative 3 minus 2, that's negative. Negative 3 plus 2, that's negative. So overall, it's going to be positive. So this interval, we put a plus sign. So regardless of what value you pick, as long as it's less than negative 2, it's going to be positive. Then we do the same thing for the rest. And negative 1. So negative 1 in here, negative 1 in here, negative 1 in here. So you'll have positive, negative 1 minus 2, that's negative, negative 1 plus 2, that's positive. So we see that this is going to be negative. So you start to see that we have different signs between the zeros. So for the next test value, we're going to plug in 1. So I plug in 1 here, and 1 here. So we have positive, negative, positive. So it's going to be negative. And the last one, you will see that when you plug in 3, it's going to be positive. All right, so we could have determined the sign just by looking at the end behavior of this function. Looking at this term right here, since it's even, and its leading coefficient is positive, it's going to behave like this at the end. So we know this is positive and positive. And then you figure out the in-between by testing values or just looking at the degrees. Now let's put this in our xy plane. So here's our xy plane. And here are the zeros. We have negative 2, 0, and 2. So positive means you're above the x-axis, negative means below. So here we are above, and then here we're below, and then here we're below, and then above. So that will be the picture roughly sketched for this equation or this function. So here you go. This is our final sketch. For the last, for the number 24, we're going to be sketching a logarithms. So we're going to start with log base 2 of x and do this shift. So our first graph is going to be log base 2 of x. So logarithm of any base greater than 1, we know it looks like this. So let's call this logarithm of base 2 of x. This point right here is 1, and there is a vertical asymptote right here at x equals 0. So all of that we know from the basic function. Now x plus 2 inside the parentheses indicates a horizontal shift going 2 units to the left. So I'm going to take the graph and slide it left 2 units, which means my asymptote will also travel 2 units to the left. So 1, 2. So it's going to be right here. That will be the new vertical asymptote. X equals negative 2. And the point 1, 0, it's going to travel 2 units to the left. So it's going to be right here. And you just make the shape of the graph. Something like this. So there you go. That's the graph of y equals log base 2 of x plus 2. And now we can also label this point. This is our y-intercept when x is 0. So for the y-intercept, we're going to set x equals 0. You'll have y equals log base 2 of 0 plus 2, which is really just log base 2 of 2. And we know log base 2 of 2 is 1. So this point is 1. And that completes our picture for this. Now for the last question, this is the last question. We're going to be sketching this parabola, label the vertex and all intercepts. Now, since this term has a negative sign, it's a parabola facing down this way. So let's fill in the rest. So I'm going to go ahead and rewrite the function this way. So f of x is going to be negative x squared minus x plus 2. So the y-intercept, that's easy to compute. When x equals 0, when you plug in 0 into the function, these are 0, so you just have 2 as the y-intercept. For the x-intercept, we have some work to do, so we're going to set f of x to 0. So you'll have 0 equals negative x squared minus x plus 2. Multiply both sides by negative 1. So you'll have 0 equals x squared plus x minus 2. Now, this can be factored. So you will have x plus 2, x minus 1. So that means our x-intercepts are negative 2 and 1. So x-intercepts are negative 2 comma 0 and 1 comma 0. So those are the x-intercepts. So I'm going to erase this so that we have more space for the graph. Now, what about the vertex? Well, the vertex, it's going to occur when x is equal to negative b over 2a. So looking at this equation, we have a is negative 1, b is negative 1, and c is 2. So those are these coefficients right here. So now if I plug this into my formula for vertex, this gives me negative, b is negative 1 over 2 times a is negative 1. So that's negative 1/2. That's the x-coordinate of the vertex. Now for the y-coordinate, we plug in negative 1/2 into the original. So we have f of negative 1/2, which would give us negative 1/2 negative squared minus negative 1/2 plus 2. And we just carefully work it out. So this would give us negative 1/4. So this negative will be canceled because of the squared. This is positive 1/2 plus 2. And now we can combine everything into a single fraction. So multiply this by 2 over 2, this by 4 over 4. So we will have negative 1 plus 2 plus 8 over 4. And that would give us 8 and 2, that's 10, minus 1, that's 9 over 4. All right, so that's the y-coordinate of the vertex. And now we can sketch. So I'm going to go ahead and erase these again, so I have more space. So the vertex will have the coordinates negative 1/2 and 9/4. And now we're ready to sketch. So here's our XY plane. We know the y-intercept is negative, positive 2. Let's call that y-intercept. X-intercept is negative 2 and 1. So negative 2 and 1. And our vertex is somewhere right here, negative 1/2. So perhaps it's right here and up here. So it will look something like this. So this is a rough sketch. So I'm going to try to redraw it. Doesn't look so pretty. So you just have to scale it in a way that it looks like a nice parabola. Right, let's call that negative 2. Maybe we can sketch it now. Something like this. It's still not the best thing, but hopefully you got the idea. So there we go. This is our parabola represented by the equation f of x equals 2 minus x squared. And this point right here, that's 9/4. All right, so I hope you'll be able to check your answers with mine, and hopefully you're able to successfully do these questions. Take care, everyone.